Aston Martin's new Honda engine was not approved early, and that is exactly why this story changes everything. All 5 manufacturers faced the same March 1st homologation deadline, while Honda pushed development until the final possible moment. Then came the nightmare. Battery failures, violent vibrations, multiple retirements, and warnings that the steering wheel could cause long-term damage to the driver's hands. But after an emergency engineering effort at Honda's Sakura factory, Fernando Alonso delivered the words Aston Martin had been waiting for. The vibrations were gone. Now the biggest question is whether Honda has finally saved Aston Martin's season, or only delayed the next disaster. Subscribe to the channel. To understand why Honda's situation became so serious, you have to start with the rule that shaped the entire project. Every power unit manufacturer faced the same deadline. Mercedes, Ferrari, Red Bull powertrains with Ford, Audi, and Honda. March 1st, 2026. That was the homologation deadline. In simple terms, that was the point when the basic engine design had to be officially submitted and locked under the regulations. Think of it like handing in the final version of a major exam. Once the deadline passes, you cannot simply tear everything up and start again because one section went wrong. Changes can still be made in permitted areas, especially for reliability. But the main design has already been committed. And this is the first detail that changes the entire meaning of the headline. Honda was not signed off early. It did not receive special approval. It did not gain extra time while the other manufacturers were still working. According to the source, Honda pushed development until the very last moment. That means Aston Martin did not begin the new era with a comfortable safety margin. It began at the edge of the deadline. And almost immediately, the weaknesses started appearing. This was supposed to be a major step forward for Aston Martin. A new engine partner, a new technical era, a fresh opportunity under completely different Formula One regulations. But the new rules also created a brutal engineering challenge. The old motor generator unit connected to the turbo had been removed. The electrical motor linked to the rear axle became far more powerful. Its output increased to roughly 470 brake horsepower. At the same time, the combustion engine produced around 540 brake horsepower. That meant the electric side of the power unit was no longer playing a small supporting role. It had become almost as important as the engine itself. And that placed enormous pressure on the battery. The battery had to deliver huge amounts of energy. It had to recover energy under braking. It had to survive extreme heat. It had to work while the car attacked curbs, changed direction, and vibrated violently. Imagine taking a normal phone battery and demanding that it power an entire house. Then imagine shaking it continuously while it works. That gives you a sense of the challenge. And Honda's problem was not only that the power unit lacked performance. The source points to severe mechanical vibrations. Those vibrations were not staying inside one part of the car. They were traveling through the power unit, through the chassis, through the steering column, and into the driver's hands. That is where the situation became much more serious than a normal reliability problem. A weak engine costs lap time. A broken battery causes a retirement. But violent vibration can attack several areas at once. It can damage electrical components. It can weaken connections. It can make the car harder to control. And it can physically affect the driver. Adrian Newey reportedly warned that unresolved vibrations through the steering wheel could risk long-term nerve damage to the driver's hands. That is not a small complaint. That is not a driver saying the car feels uncomfortable. That is a potential safety issue. Imagine gripping a machine that shakes constantly. First, it is irritating. Then your hands begin to tire. Then numbness can start. Now imagine that happening while you are controlling a Formula One car at enormous speed. You are braking at the limit. You are changing direction with tiny movements. You are managing switches, energy deployment, tire grip, and radio communication. And the steering wheel is sending repeated vibration through your hands for lap after lap. That can affect concentration. It can affect precision. It can affect confidence. And without confidence, a Formula One driver cannot attack. But here's where the problem became even more dangerous. The vibration may not have been separate from the battery failures. The two issues could have been connected. Mechanical vibration can place repeated stress on sensitive electrical parts. It can loosen connections. It can damage internal systems. It can attack the same weak point thousands of times until the component finally fails. Think of bending a paperclip. One bend usually does nothing. But bend it again. Then again. Then again. Eventually, it breaks. A Formula One battery and its surrounding systems face forces far more complex than that. And if the vibration occurs at the wrong frequency, the damage can build rapidly. That may explain why Aston Martin's early failures did not look isolated. In Australia, Fernando Alonso retired after 15 laps with a technical issue. The message from the team was direct. Stop the car, we have an issue. Lance Stroll also suffered engine-related problems and finished unclassified. That was already a bad start. But one difficult race can happen. New regulations create surprises. New power units create unexpected failures. Teams expect some early pain. Then came China, and everything became harder to dismiss. Stroll retired after only 9 laps with a suspected battery failure. Alonso continued longer, but the vibrations became so severe that he said he physically could not continue much longer. He retired around lap 32. 2 cars. 2 retirements. 1 suspected battery problem. 1 driver physically struggling with the vibration. And Honda's response was unusually blunt. There was no excuse. That matters. Manufacturers usually choose careful words after a failure. They say the issue is being investigated. They say the data will be analyzed. They say lessons will be learned. But Honda did not hide behind gentle language. There was no excuse. That statement revealed the scale of the disappointment. This was not the standard Honda expected. This was not the beginning Aston Martin had prepared for. And this was not one simple issue that could be fixed overnight. Because if the vibration was damaging the battery, then Honda and Aston Martin were not solving 2 separate problems. They were chasing one deeper problem that was spreading through the entire car. That kind of failure is extremely difficult to diagnose. The vibration may begin in the power unit. The chassis may amplify it. The mounting system may transfer it. The steering column may carry it. The battery may suffer from it. And the driver feels the final result. It is like hearing a strange noise inside a house. You think it comes from the wall. Then you realize the wall is only carrying the sound from the pipes. Then you discover the pipes are vibrating because of a machine somewhere else. Finding the real source takes time. And Formula One gives teams almost none. Every race arrives quickly. Every failure costs track time. Every lost lap removes valuable data. And while Aston Martin and Honda search for answers, the other manufacturers continue improving. That is why the idea of an early sign-off is so misleading. An early approval would suggest control, confidence, preparation. But the real story was the opposite. Honda worked until the final moment. Then the new season began, and Aston Martin immediately entered a reliability crisis involving the battery, the engine, the chassis, and even the physical safety of the drivers. But the failures in Australia and China were only the beginning. Because the next race introduced a completely new problem, and that was the moment Aston Martin realized it was not fighting one weakness, it was fighting an entire chain of them. That chain became impossible to ignore at Suzuka. Fernando Alonso finally completed his first full race distance of the season. That should have felt like progress. After the failures in Australia and China, simply reaching the checkered flag mattered. But Alonso finished 18th. So Aston Martin had solved one problem for one car, only to expose another. Finishing was possible. Competing was not. And on the other side of the garage, Lance Stroll did not even make it that far. He retired on lap 30 with a water pressure failure linked to the combustion engine. That was described as a new failure mode. Those 4 words changed the mood completely. A known problem is painful, but manageable. Engineers can study it. They can reproduce it. They can test a solution. But a new failure mode means the list is getting longer. First came the battery concern. Then the severe vibration. Then the physical strain on the drivers. Now water pressure had entered the picture. This was no longer one weak component. It was a system under attack from several directions. And that creates the worst kind of engineering crisis. Because every fix consumes time. Every new failure creates another investigation. Every investigation delays the work that should be improving performance. Aston Martin was not only losing races, it was losing development time. That matters more than it sounds. A Formula One weekend is not just competition. It is also a test. Every lap teaches the team something. How the tires behave. How the car reacts in traffic. How the battery temperature changes. How the engine performs over a long run. How the gearbox responds when the fuel load falls. But a car that retires early cannot provide the full picture. The engineers lose the end of the experiment. It is like trying to understand how long the phone battery lasts after using it for only 10 minutes. You can make guesses. You can study the first part. But you do not know what happens when the system is pushed for hours. That was Aston Martin's problem. The team needed data to improve the car, but the car was failing before enough useful data could be collected. And while Aston Martin kept stopping, its rivals kept learning. Mercedes learned. Ferrari learned. Red Bull powertrains learned. Audi learned. Every completed race gave those manufacturers another set of answers. Aston Martin and Honda were still trying to identify the right questions. That is why the period before Miami became so important. The calendar created an extended gap between the races in Saudi Arabia and the United States. Aston Martin and Honda used that time to attack the vibration problem directly. A car was sent to Honda's Sakura facility in Japan. That decision revealed how serious the situation had become. This was not a small software adjustment that could be handled through emails and simulation. The team needed the physical car. Honda needed to understand how the engine behaved inside Aston Martin's chassis. The engineers needed to study how the vibration traveled, where it began, where it became stronger, which components were absorbing it, and which components were being damaged by it. Because the engine and the car could not be treated as separate machines. Honda built the power unit. Aston Martin built everything around it. If the engine created a vibration, the chassis could amplify it. If the mounting points reacted badly, the vibration could spread. If the battery or control electronics sat in a vulnerable position, the repeated forces could attack them every lap. One side could blame the engine. The other could blame the installation. But blame would not make the car reliable. The entire package had to be understood as one system. That is what made the Sakura work so important. It forced Aston Martin and Honda to solve the problem together. And this is where the first genuine sign of hope appeared. By the Miami weekend, Alonso was asked about the vibration. His answer was direct. Gone. He went further. He would say it was gone. That was a massive statement. Not because Aston Martin had suddenly become fast. It had not. Not because Honda had suddenly produced the best engine. The source does not support that. The importance came from something more basic. Aston Martin and Honda had identified a severe problem, worked together, and produced a change the driver could immediately feel. That is the development process every team needs. Problem. Investigation. Solution. Confirmation. And in Miami, both cars completed the sprint and the Grand Prix. For the first time that season, Aston Martin had a completely clean weekend. Alonso and Stroll finished 15th and 17th in both events. Those positions were not impressive. But after Australia, China, and Japan, finishing every session mattered. It proved that the car could survive. It gave the engineers complete race data. It allowed the drivers to experience the power unit over a full distance. And it gave Honda evidence that the vibration work had achieved something real. That was the first moment when Aston Martin could stop thinking only about survival. But the relief lasted only a few seconds. Because when one major problem disappears, the next one becomes impossible to hide. Alonso described the gearbox behavior in Miami as almost impossible to drive. That revealed the next layer of the crisis.